Good morning. This lesson today is really just a second lesson because the video that I made first, the volume was so low. So I'm not quite sure how that went down, but I'm learning things, you're learning things. And if you have already watched that video, if you were able to hear me, then just don't worry about this video. So we are doing factoring by the grouping method. And if you remember, factoring is taking a bigger expression and breaking it up into smaller pieces that can multiply together to give you that same expression you started with. So for example, if I have the number 6, 2 times 3 are its factors. I have 2 chunks of 2 times the number 3, right? So both of those 2 and 3 are factors of 6. Now, when we get to longer expressions that have variables in them, then our factors, instead of just having numbers like 2 times 3, I'm going to have parentheses. I'm going to have quantities that are being multiplied by each other. So let's get started. All right, factoring by grouping specifically has expressions with 4 terms. All right, and we are going to group those terms so that we can factor both of them using the greatest common factor. So today we are going to go over step 1, step 2, and step 3. We are not going to do step 4 today because we have not yet learned how to multiply binomials times binomials, but we'll get there. All right, so on your worksheet, your first example in step 1, this one right here, the next 2 steps should be blank. They put a line. And what this line does is it groups the first 2 terms and the last 2 terms. So I'm going to look at both of those terms, and let me actually use a different color. I'm going to look at this first term, and I'm going to ask myself, hey, what is the GCF, or the greatest common factor, between x to the third and 7x squared? Now, the numbers, I have 7, and I have that invisible 1 here. All right, so if 1 is your only common factor, then we don't consider that really to have a greatest common factor. So I look at the variables, and I have 3 x's to give here, and I have only 2 x's to give in my second term. So only 2 of those x's would be considered the greatest common factor. All right, and here I see x squared. So that is my GCF of x to the third plus 7x squared. So again, I can use distributive property. X to the second times x gives me x to the third, and x to the second times 7 gives me 7x squared. So all I did was do the greatest common factor of x to the third and 7x squared. Now I'm going to focus on the second pair, right? So here I have a positive 2x and a positive 14. So I look at the variables and I only see x with the 2. So because I don't see it with the 14, it is not a GCF that's a variable for these two terms. So now I look at 2 and 14. And 2 is the GCF. It is the biggest number that can divide into 2 and into 14. So my GCF for my second pair of terms is 2. And 2 times x is 2x, and 2 times 7 is 14. All right, so basically I've just taken the greatest common factor from each pair of binomials. All right, so now this is the interesting part. This is where factoring by grouping is really happening. So far we've just done greatest common factor. Now, if you look, the x squared and the 2 each have a common chunk, a common parentheses of x plus 7. Now, if what is inside your parentheses at this point is not the same, then you did something wrong. You might have to reorder your polynomials, right? There are a couple things. Maybe you did a sign that was wrong. But at this point, both of your parentheses should be identical. And in the other video, I believe she calls them the twins, right? It's got to be identical. All right, so now that we have these twins, these identical parentheses, that becomes my new greatest common factor. Both this first group and the second group both have a common factor of x plus 7. So I can put that here. Now, what's left over, x plus 7, this whole term times x plus 7, the whole term times x squared gives me my first group. Okay? Now, x plus 7 times 2 gives me my second whole group. All right? And now I have two parentheses. Let me erase this a little bit. So I have two parentheses, x squared plus 2 and x plus 7. And now I have factored by grouping. So I've taken my original x to the third plus 7x squared plus 2x plus 14, and I have factored it by grouping into x squared plus 2 in parentheses times x plus 7 in parentheses. All right, so now we're going to do one example together, and then you can go right ahead and watch that next video and do your TOC. Actually, I forget which one you're on, but I think it's like TOC 5, 7, 8, maybe. Okay, so example 1, factoring with the grouping method. So I am going to take this and put a line here. So I have one group, and here I have two groups, my second group. All right, so let me make the first group red. So I'm just looking at these two terms. Now, x to the third plus 4x squared. I don't have a number that could belong in my greatest common factor, but I do have a common variable of x. So x to the third has 3 x's to give, x times x times x. And my second term has 2 x's to give, x times x. So my greatest common factor between those two is x to the second. Now, I'm going to use distributive property to help me figure out what else goes in the parentheses. So x squared times x would give me x to the third. So I still have x times x, and now times another x gives me x to the third. Now, x squared times 4 gives me 4x squared. And again, the plus needs to match the plus above. Okay, now let me use green, and I'm going to go for this second group. So here I have plus 8x plus 32. they do not have any x's in common. So I'm going to look at the 8 and the 32. Now, I know that 2 goes into both of these, right? 2 goes into 8 4 times, and 2 goes into 32 16 times. But it is not the biggest common factor. The biggest common factor is 8. So now, again, I'm going to use my distributive property to help me. 8 times x gives me 8x. And 8 times 4, and that's a plus, sorry guys, 8 times 4 gives me 32. Okay, so now I'm looking for those twins. I'm looking for the same identical terms inside the parentheses. So I see x plus 4 and x plus 4. That becomes my new common factor. So between the red set and the green set, x plus 4 in parentheses is common to both of them. It would be kind of like having x squared y plus 8y, and y would be the common factor. All right, so that's a little tricky just to kind of get in your head. But here I'm using these common parentheses, the twins as we'll call them, and I'm going to put that here, x plus 4. All right, now I'm going to use x plus 4 times x squared. So I know x squared is going to go in my next parentheses. And I also have x plus 4 times 8. So plus 8. So really, this is what they have in common. And this right here are the greatest common factors of the red group and the green group. All right, and if you see that right here, in fact, I want you guys to notice that they put the x plus 4 second and the original GCFs first. And here is the new common factor. Right, I see it here and here. It does not matter. That is commutative property. Because this is multiplication, right? Whenever parentheses are touching, that means multiply. Whenever you're multiplying terms, you can put them in either order as long as what's inside the parentheses is the same. Okay? So, right, I don't mind if I write it like this, or I could also write it like this. X plus 4 times x squared plus 8. Those are both the same expression. All right, so hopefully the volume is fine. I'm going to check it after I do this. Please write down your questions. Again, I forget mine. All of your notes should be uploaded to the note tracker. So if you're having issues with that, please shoot me an email. And that is it for today. Hope you guys have a good one.